Hi, welcome back. This is Rakesh Naik. Today we are going to take one more application of stack. Today we are going to convert a infix expression to a postfix expression using a stack. But before we start, a small information I'd like to say. In this channel we produce every video in two different languages, Hindi as well as in English. If you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. We have already discussed about what is a stack, how to represent a stack, what are the operations available in a stack, and in this series we are going to talk about an application in which we are going to transform a infix expression to its postfix expression. If you have not watched all those videos, in the I button link are given. Kindly follow it. So before we start about conversion of infix to a postfix expression, let us see what kind of expression will say infix and what kind of expression will say postfix expressions. If an expression is given a plus b in infix expression, then we can convert it to a postfix expression when we write a b plus. It means whenever the operator is in the middle, we'll say infix expression. When the operator is kept at the last, then we'll say it is a postfix expression. Similarly, take one more example. A plus 6 star b minus c. It is in infix expression, and if I want to convert this to postfix expression, it will be, I'll convert this bracket works first. So it will become a6 plus, then this bracket I have to concentrate, bc minus, and after doing this bracket works, this multiplication I have to do. So at last I have to write multiplication. So this is the required postfix expression for this infix expression. Basically, when we write a expression like a plus b star c, we really don't know what is the meaning of it. Whether it means a plus b star c or a plus b star c. So that's why bracket plays an important role when we write a infix expression. So before we start converting a infix expression to its postfix expression, one thing that is required is knowing the proper meaning of this expression which is in infix. It means to know the proper meaning, what the infix expression says, we need proper parenthesis. So a properly parenthesized expression can be understood properly and hence can be converted properly. So let us see the general process what we are going to do. In the first step, what we are going to do, we are trying to scan the infix expression from left to right till we end the last of the expression. While scanning from left to right, we can encounter a left bracket, we can encounter a right bracket, we can encounter a character or a digit, we can encounter an operator. So for all these things, we have to do certain work. So if a left parenthesis is encountered, we have to push it onto the stack. If a digit or a character is encountered, then we have to add to the postfix expression. If a right bracket is encountered, then we'll repeatedly pop and add to the postfix expression until the left bracket encountered. And whenever the left bracket is encountered, we'll discard this bracket. And if an operator is encountered, then check the top of the stack, pop it and add to the postfix expression until the popped operation is same or higher precedence than the scanned operator. And then push the scanned operator onto the stack. If the scanned operator is having higher precedence, then add to the postfix expression. Repeatedly pop the stack and add to the postfix expression until the stack is empty. So this is the general process that we are going to adopt in order to convert a infix expression to a postfix expression. So for a better understanding, let us see an example. Let us say this is my expression given and I want to convert this expression to a postfix expression. So what I have to do? I have to start scanning the infix expression from left to right. So the first character that I encountered is a left parenthesis. So what I have to do? I have to push this left parenthesis onto the stack. So the left parenthesis is now added to the stack. The next character is again a left parenthesis. So I have to do the same thing. I have to add it to the stack. The next thing is a number. So when a number appeared, what I have to do? I have to add it to the postfix. So if a postfix expression I am having, I'll add it to this postfix expression. The next character is a operator plus. So for that, what we have to do? We have to add it to the stack. So plus is added onto the stack. The next character read is a numerical value, that is 5. So I'll add it to the postfix expression. So in the postfix expression, I'm having 3 and 5. The next scanned character is a right parenthesis, and when the right parenthesis will appear, I'll pop from the stack till the left parenthesis appear, and whenever I'll get a left parenthesis, I'll discard it. So from the top of the stack, I'm having plus, so I'll add it to the postfix expression and I'll discard the left bracket. So the next character that is scanned is minus. So minus is the operator. What I have to do? I have to push this onto the stack. So the minus symbol is on the top of the stack. The next character is a numeric value, that is 9. So what I have to do? I have to add it to the postfix expression. And the next character is a right parenthesis. For the right parenthesis, what we have to do? We have to pop from the top of the stack and add to the postfix expression until the left bracket appears. And we have to discard the left parenthesis. So now you can see the stack is empty and we reach to the last character of this infix expression. So we got this postfix expression like this: 3, 5 plus 9 minus. I hope you understood this. Now let us try to take one more little bit more complicated example so that your understanding will become better. Let us see. The first character that is scanned is a left parenthesis. What I have to do? I have to push it onto the stack. Next character is again a left parenthesis. What I have to do? I have to push it onto the stack. The next character is a number, numeric value 3. I have to write it to the postfix expression. The next character is a operator plus. So I have to push it onto the stack. The next character is a numeric value 5. So I have to write it into the postfix expression. And the next character is a operator star. Now you can see a operator is here pointed by the scanner and another operator is there at the top of the stack. So what we have to do? We have to push it onto the stack. Because the precedence of star is more than the precedence of plus. Now the next character is a numeric value, that is 2. So I have to write it in the postfix expression. The next character that I got is a right parenthesis. So I'll pop from the top of the stack until the left parenthesis appeared and I have to discard the left parenthesis. So this is what I got. Now the next scanned character is minus. Minus is an operator, so I have to push it onto the stack. The next character is a numeric value 9. I have to write it onto the postfix expression. And the next character scanned is a right parenthesis. For that, I have to pop from the top of the stack and write in the postfix expression until the left parenthesis appear. Now you can see we reached to the last character of the infix expression and top of the stack is now pointing to -1, indicating that the stack is also empty. So you can get the required postfix expression as 352 star plus 9 and minus. Let us try to make it little more complicated. Now here the same problem is there. Here the operator star and plus are interchanged. Now you see how the algorithm changes the required postfix expression. Now if you start scanning, the left parenthesis appeared. I want to push it onto the stack. The next character is again a left parenthesis. Again I have to push it onto the stack. The next character is a numeric value 3. So I have to write it in a postfix expression. The next character is an operator star. I have to push it onto the stack. The next character that I scanned is a numeric value 5. I'll write it in the postfix expression. And the next character is an operator plus. Now you can see the precedence of plus and the precedence of star, which is there on the top of the stack. So star is having higher precedence than plus. So what I have to do? I have to take the star and write it in the postfix expression and take plus and push it onto the stack. Something like this. Now the next character is a numeric value 2. So as usual, I'll write it on the postfix expression. The next character is a right parenthesis. So what I have to do? I have to pop out all the operator there on the stack till the left parenthesis appeared. So the left parenthesis was gone, discarded. The next character that I will be scanning is a operator minus. So I will push it onto the stack. The next character is a numeric value 9. I'll write it onto the postfix expression. And the next character scanned is right parenthesis. So what I have to do? I have to pop it from the stack till the left parenthesis appeared. So minus is taken out and wrote it in the postfix expression, and the left parenthesis is now discarded. Now you see with the same expression and the change in the operation, the expression changed. Here for this infix expression, the postfix expression is 3, 5 star 2 plus 9 and minus. I hope you understood this algorithm, and along with that you understood the example. So let us see the program segment. So you are having a function called infix to postfix. You are passing infixed expression and you are passing a postfix expression. You are taking two variables I and j assigned to 0, and you are writing postfix expression to be 0. And you are going to do these set of activities till you reach end of the expression, that is \0. If in the infix expression the character is a left parenthesis, then you are going to push it, increment I. If you are going to get a right parenthesis and the top is not -1, it is not empty, and the top is not left parenthesis, then what you have to do? You have to pop the stack and write it to the postfix expression, and j will be incremented. If top is -1, then you can say it is a improperly parenthesized or it is not a valid expression. Otherwise, you have to pop the expression and write it in temp. I will be increased by 1. If the infix expression is a digit or an alphabet, then what you have to do? You have to take the infixed expression and write it in the postfix expression, and I and j variable you need to increment. Otherwise, you are getting a plus or minus or star, slash or percentage symbol. It means all of them are operators. In that case, you have to find the priority of the operator. If priority, the top of the stack is having higher priority than the scanned element, then what you have to do? You have to pop it and write it in the postfix expression. Otherwise, you have to push the operator onto the stack. So you have to continue this while top is equal to 1 and top is not equal to left curly bracket, then you have to pop it up and write it in the postfix expression. J will be incremented by 1 and at last you are writing the last character of the postfix expression, that is \0. I hope you understood the algorithm, the example, the program, the basic ideas that we used. And if you understood the total process, give a thumbs up and share among your friends. In our next video, we are going to see yet another application of stack. So see you then. Take care. Bye.